and I'm back, and I'm going to finish up Chapter 5, Elementary Particles and Forces of Nature. I'm going to be talking about the four forces, which are very important. They are gravity, electromagnetic force, the weak force, and the strong force. But first I'm going to talk about gravity. It's very important, and you and me both know about it. Now, gravity is a very weak force. Like, we wouldn't even notice it if it weren't for one special property it has. It always attracts. Now let me explain. Say this is the sun, and this is the earth. Now the earth is attracting the sun, a force of say 2. The sun's attracting the earth, say at a force of 20. Now normally, it would just be like 20 and 2, but because they're both attracting each other, it comes up with a total of force 40. It multiplies because they're both attracting. With the electromagnetic force, which is why protons attract electrons and electrons repel each other, it would do something not very similar. This would be the sun, this is the earth, and the earth is attracting the sun, but also repelling the sun because of the fact that they both have electrons and protons. So say it's repelling 2 and attracting 2, they cancel each other out. Sun is repelling 20 and attracting 20, and they cancel each other out. So the net force here is 40, and the net force in electromagnetic force is 0. And that's why we really feel only gravity. Now the weak force is a very interesting force because it causes radiation. This force is it changes the types of quarks, the flavors and colors. It can turn protons into neutrons and the other way around too. It causes radiation, which is a bad thing, but it also causes nuclear fission, which keeps our sun burning. Now there's something called the strong force. The strong force is what keeps the atom together. If you really think about it, you would wonder why the protons in the nucleus won't repel each other. But they don't because of the strong force. The strong force is carried by something called the gluon. Now the gluon has a very interesting property. It will only bind particles together so they'll have a value of the color white. It'll only bind a red, a blue, and a green particle color to form white. Like, it'll only make protons and neutrons, and it won't make any other combination because of the colors. It'll also bind let's say a red down quark with an anti-red down quark, and that also equals white. So that's why we have protons and neutrons, and they don't just float around as quarks. They also, because of the fact that the gluons themselves also have color, they won't let a gluon stray by itself, and the gluons will have to form together into an unstable particle called a glue ball. Now, because of this, we can think that finding a quark or a gluon by itself is almost impossible, but it's not. A theory came out called GUT, and that is a theory that unifies the strong force, the weak force, and the electromagnetic force. When you increase the energy, the higher you go, the more stronger the electromagnetic force and the weak force get, and the strong force gets weaker, eventually until they all become the same thing. So in reality, they're all the same thing, but at lower energies, they look different. It's like a roulette ball. At high energies, the ball spins around, looks like one ball. But when you lower the energy, the ball could have like it looks 36 different ways for each of the slots. Now, people have been trying to unify gravity with the GUT, but gravity just doesn't fit in because of its odd properties. GUT, we're not really sure if it's true, because to get the approximate amount of energy we need a machine the size of the entire solar system, and that's not very possible. Now, I'm going to talk about something else. During the GUT force, it's predicted that matter, the normal matter will turn into antimatter, and antimatter may turn into matter. But during this, a normal neutron would turn into 2 particles of antimatter. So in other words, after this, there'd be more normal matter than antimatter. And because GOT could have occurred any time during the Big Bang, that's why we have more matter than antimatter. And that's all I have to say about Chapter 5. I'm going to see you next time when I talk about Chapter 6 and black holes. Bye.